Once again, good morning and welcome to our general mathematics class. Today we'll discuss about solving problems. So we'll have lesson 3.5. We're done with the introduction to exponential functions, how to solve equations and inequalities. And today we'll talk about problem solving. Now, let's start reciting today's memory verse. And it's found in Deuteronomy 10, verse 17. It says, For the Lord your God is God of gods and the Lord of lords, the great, the mighty, and the awesome God, who is not partial and takes no bribe. At the end of today's class, you will answer our MBCA boosters, and it's a part 2 of what you did last week. We'll talk about exponential blessings in different ways. Blessings can come in many forms. It can be through children, longer life, good health, and even money. Last week, you have discussed on these blessings among women in the Bible. And today, you'll discuss it with some Bible men. Just choose two again. You can either share to us the blessings of Joseph of Egypt, Mordecai, King Hezekiah, Lot, and Daniel. Let's go to our lesson. At the end of today's lesson, you'll be able to solve problems involving exponential functions, equations, and inequalities. And our venture activity is related to last week's venture activity. It will ask you that suppose 5 days already passed after the start of the insect infestation. How big is the area affected by the increase of insects? Now let's start with our discussion. Last week, we have talked about exponential function. And an exponential function is a function wherein you will see x, or the variable, in the exponent. Again, in the exponential function, the variable is in the exponent. Now, if your base is greater than 1, then remember, our graph will go up. It means that it is an increasing function. We call this the exponential growth function. But if your b is between 0 and 1, then our graph, I'm really sorry for the noise, will go down. It means this is a decreasing function, or we call this the exponential decay function. So again, if b is greater than 1, then we are growing, we do exponential growth. And if b is between 0 and 1, like for example, 1/2 to the power of x, then we experience the exponential decay function. What else? If you talk about exponential growth, then we need to compute for the growth factor. While if we will have the exponential decay, we need to solve for the decay factor. How do we solve that? For example, the growth factor is the new value over original value. So for example, population grows by 10% each year. Then how do we solve for our growth factor? That's going to be 1.10 or 1.1. Or another, for example, this year, what's this? Wait for a while. For example, this year, our population is 200. Last year, our population is 100. So how do you solve for the growth factor? It's just the new value, that's 200 over 100. So our growth factor is 2. It means that the population doubles. Now, how about for the decay factor? The decay factor is still of the same formula. The new value over the original value. For example, if death rate is at 10% per year, then we say that our decay factor is 0.9. Why? 1 means whole minus the 10%. That is 0.9. Or another, if the original price is 200 and then it's on sale and then the new price is 150, we just have 150 over 200. That is 0.75. This is our decay factor. A hint, if we talk about exponential growth, the growth factor is more than 1 because 1 means whole, the 100% of the original value. If we talk of decay factor, the original value is less than 1. So now, in this problem solving, we'll have 5 exponential models. In mathematics, once you talk about models, we say it's formula. So let's talk about 5 different formulas. Model number 1 is used for usually for any increase except money, like population increase, population of bacteria, of human growth, any of that one. Next, models number 2 and 3 are used for money. Model number 2 is for compounding interest, while model number 3 is for compounded continuously, still for money, but compounded continuously. Next, model number 3, give me a moment, please. Now, in exponential model number 4, the fourth one, it will talk about exponential decay. Like example, death rates, epidemics, this one. What discounts, it's on exponential decay. But investments, it's exponential growth. And model number 5 will talk about a specific exponential decay we call half-life. Now let's have the meaning of each symbol. A, for any of this, A means initial amount. Example, the population this time is 1,000. This is the A, our initial amount. While B is for the growth factor and T is for time. For the second formula, P means principal. What's the starting amount? Example, I'll invest 10,000. 10,000 is your principal. R is the interest rate. So example, we have 25%. It becomes 0.25. N is the number of compounding periods per year. Example, if it's compounded annually, it means once a year, right? So N is 1. If we say compounded monthly, how many times in a year? N
12.
is, very good, N is 12. If we say compounded quarterly, how many times in a year?
4.
4, very good. So N is equal to 4. So that's our N. While T will stand for the number of years. For model number 3, again, P is the principal, the starting amount, and E is the same as your E in your calculator. That is why you could not solve this problem without the use of your calculators. You really need to have your calculators with you and check for the symbol E. In the next formula, again, A is our initial amount, the starting population. B is your decay factor, and T is time. Well, for Halflife, A is your starting amount. 1/2 is not arbitrary, it's constant. 1/2 is constant because we talk about half-life. T is the number of years. H is the half-life of radioactive substances. Let's have two problems for each of these models. Let's start with number 1. An insect population grows at a rate of 30% each day. There are 100 insects today. How many will there be tomorrow? Now, we talk about population growth. So we'll take the first model. But we need to identify the given details first. A is the initial amount, 100 insects. B is your base, your growth rate. Since it grows at 30% each day, then our growth rate is 1.3 or 1.30. 30% is the rate. I told you 1 means the original. So let's have 1.3. Now, what will be our time? If you check, the growth rate is per day. So our time elapsed must also be in a day setting. So 100 insects today, the question is, how many will there be tomorrow? Tomorrow. So we only have 1 day that elapsed. Ling, excuse me first. Ling, si Baba. So our T is 1. Let's solve for our population tomorrow. That's Y equals AB to the power of T. If you're using a 2-line calculator, the exponent can be done this way, the caret. So you can have that for the exponent. So we have 100 times 1.3 to the power of 1. So the value of Ry is 130. It means that there will be 130 insects tomorrow. There's a note at the bottom. If the problem deals with population, then the answer must be whole numbers. So you need to drop the decimal point. Like example, if the answer for this is 130.5, drop the decimal point. Do not round up because you see, we could not look for the other 0.5 insect. So just drop the decimal. The next problem, similar to that one. Still on insect population, and it's about growth. So we will have the same model. Y equals AB to the power of T. Okay. What's the growth? Still at 1.3. That's our growth rate. Our A is still 100. But here's the question. How many will there be a week from now? What will be the value of our T? Can anyone tell me?
7.
Very good. It's 7. Why? Because there are 7 days in a week. Now, ma'am, what if the given in the growth rate is each month? Then you need to also write your T in the month format. So you have Y equals AB to the power of T, 100 times 1.3 to the power of 7. The answer to that is 627.49 insects. I told you that when you talk about population, you drop the decimal. So the final answer will be 627 insects. Any questions for model number 1? No questions? Feel free to raise your hand if you have questions, okay? Let's go to model number 2. Problem number 3. Stent invested 10,000 at an annual rate of 8% compounded annually for 3 years. How much money will he have after 3 years? We're using the second model, so that will be this one. Now, let's find first the given details. P, our principal, is the starting amount is 10,000. RR, which is the rate, is 8%. You convert it to decimal, that's 0.08. N, compounded annually. It means 1 time a year. So our N is 1. And RT is the number of years for 3 years. So let's solve. Y equals 10,000 times 1 plus R over 1 to the power of NT, 1 times 3. Using your calculator, the answer will be 12,597.12. Now, here's a reminder at the bottom. If the problem deals with money, don't ask me anymore. Ma'am, 2 decimal places. Remember that in the money, we have up to the centavos, right? Up to 2 decimal places. So we must have it in 2 decimal places. Again, for population, whole number. For body, 2 decimal places. Let's go to problem number 4. Still about money, and it's compounded quarterly. So we will still use the second model. Now, if I invest 20,000, that's the principal, at 12%, that's the rate, compounded quarterly. How many times in a year? That
4.
is very good, 4 times a year. How much money will I have at the end of 2 years? This is my time. You know what? In any problem solving, especially in this type of problem, you just need to identify, number 1, what is the model? What's the formula? And second, what's the given? The rest of the magic will be in your calculators. So you need to identify the details, the given details properly. 4 times 2. Using your calculators, the answer will be 25,335.40. Let's go to problem number 5. What's the difference between model number 2 and model number 3? Now, in model number 2, the compounded has a specific period, like compounded quarterly, compounded annually, compounded semi-annually, compounded monthly. Ma'am, what if it's compounded, but the time is not specified? If the time is not specified, then it's understandable that it's compounded annually. But there's another compounding model, and we call that compounded continuously. Now, if you'll read compounded continuously, what's the difference of that? In compounded annually, your money will just increase every year. In compounded monthly, your money increases the next month, then the new amount will be compounded again, will increase again in the next month, and the same will happen. But in compounded continuously, every moment, your money is increasing. Now, let's have the following given details. Sted invested at 10,000. That's our principal. At an annual rate of 8%, that 0.08, that is our rate. Compounded continuously, so we'll use E for 3 years. That's our time. So we will use the third model. That's Y is equal to P E to the RT. Our principal is 10,000. E is constant. Our rate is 0.08 times 3. No problem if you're using a 4-line calculator. But if you're using a 2-line calculator, be sure to have it in 10,000 times E. Please enclose it in a parenthesis, caret, 0.08 times 3. Okay? Hope you are trying this time with your calculator, so you can check whether your calculator is working well with the formula. With this, the answer is 12,712.49. Let's compare it with problem number 3, because in problem number 3, we have the same problem, pero compounded annually. You check. In compounded continuously, our money is 12,712.49. But if you'll go to problem number 3, in annually, your money is 12,597.12. So compounded continuously will give you a bigger money, a larger money compared to other compounding periods. Let's go to problem number 6. The same problem with problem number 4. The only difference is it's compounded continuously. So we'll have 20,000, that's our principal. Our rate is 0.12. Compounded continuously, that's our E. And our time is, wait first, our time is in 2 years. Now, let's use model number 3. We'll have Y equals P E to the RT. That's 20,000 times E, 0.12 times 2. With your calculator, the answer is 25,424.98. We compare it with problem number 4. Here, only 25,335.40. So, which do you prefer? Compounding continuously or other compounding periods? Now you see, it depends on the situation. If it's a money for investment, compounded continuously is better since it will give you a bigger amount of money. But if you have loans, utang, do not go for a compounding period that happens frequently. The fourth to the last one. Problem number 7. A computer set is sold at 30,000. That's our A. With a 10% discount. Oh no. We are talking about discounts. So we'll have the formula, the model number 4. It's 10% discount. So we'll talk about the decay rate. The decay rate will be 90%. Or that is 0.9. That is 100% minus 10%. Now, what is the discounted price? Our time will be same, 1. So we have 30,000 times 0.9 to the power of 1. Because it's only one discounting period. Using your calculator, it will give you an answer of 27,000. Any questions? No other questions? Let's go to problem number 8. In problem number 8, the keyword is depreciates. It means the value lowers down every moment. So the price of a ripe mango depreciates at 20% per day. Possibly going ma-overripe na, hinog na kaayo. So para mabawi ang capital, it depreciates at 20% per day. If a kilo of mango is sold at 100 pesos, that's our A, what price will it be sold after 3 days? Our T is 3. Now, our decay factor, that's 20% lower, so it's at 0.8. Let's solve for the new value. So we have 100. Our B is 0.8 to the power of 3. So the new price of the mango is 51.20. Any questions? No other questions?
Kanang excuse me, ma'am. Kanang sa unsa ba formula ganina, ma'am, katong sa na ta, ma'am? Tong sa compound continuously. Iram na diretso no mo automatic ra man na mo calculate sa calculator, no?
Yes. You look at your E in your calculator.
Sige, ma'am.
Do you see the E in your calculator? That is the one that you will use. It's near
sige.
to log and ln.
Oo.
Okay. The next
Salamat.
one. For some calculators, the E will not work the same as the formula. So you check first before you do your quiz whether it's your E, the one in the natural E, or you're looking for the shift E or alpha E. You check with your calculators because each calculator works differently. Let's go to the half-life. What do you mean by half-life? In radioactivity, half-life is the interval of time that your amount of radioisotopes or radionuclei will decrease into half. For example, you know what's the reason why chemists did not buy new radioisotopes in bulk amount? Like, why don't they buy it in 50 kilograms, sinako? They only buy it in grams. It's because radioisotopes have half-lives. Example, if I'll buy a radioisotope with 50 grams and its half-life is 1 day, what will happen? It means that after 1 day, my 50 grams will deplete. It will become 25 grams. Even if you seal it in a container, it will really deplete. Why? You see, they go through an emission process. Or we also have, it looks like this one. You imagine a water that keeps on boiling. It evaporates, right? So a certain amount of time, it will no longer be the same. The same is true to radioisotopes. So after 1 day, it will only be 25 grams. After 2 days, you only have 12.5 grams until your radioisotope will continue on depleting. Now, there is a table for half-life. Like example, you see here, cobalt-60, its half-life is 5.27 years. Or if you have polonium-218, its half-life is 3 minutes. If you have uranium-238, It's 4.5 times 10 to the power of 9 years. And it's different with uranium-235. You have your chemistry class today, right? STEM students. So you can ask Sir Biclar more on how do these radioisotopes work. In my class, let's just talk about half-life. Now, if we have the half-life problem, we use the fifth model. Y is equal to A times 1/2 to the T over H. Remember that T and H must have the same unit. So if your half-life is in terms of years, then your T should also be in years. But if your half-life is in terms of days, like this one, then your time must also be in days. That's problem number 9. A hospital purchased 50 grams, that's our A, of iodine 131. After 10 days, that's our T, what will be its remaining amount? I placed the note there so that I will not keep on placing the table. That the half-life H is 8 days. So the C after 10 days, that will be 50 times 1/2 to the power of 10 over 8. Using your formula, the answer will be 21.02 grams. Okay, so the last problem. A laboratory purchased 200 grams of krypton-91. This is our A. After a minute, that's our T, how much of the radioactive substance will be left? Note that the half-life of krypton-91 is 10 seconds, that's H. Our half-life is in seconds. So our time must also be in seconds. So what will be our T? What's the value of our T? Our T will be 60 because there are 60 seconds in 1 minute. So let's have this formula, model number 5. First, our initial amount is 200 times 1/2 to the power of 60 over 10. And that's 200 times 1/2 to the power of 6. Again, using your calculator, I should tell you, you need to get a good calculator. That the answer is 3.125 grams. Let us round it off. It's going to be 3.13 grams. Any questions? That ends today's lesson. Let's have a very brief review on the different models. Again, if you're talking about population growth, then we use model number 1. If we talk about money, you can have model number 2 or 3. Do model number